So we're going to take care of example number 1. This is a word problem. And the word problem says, substituting into a formula. It says that a pediatric nurse uses Young's formula. Young's formula is this right here. Okay? That's our Young's formula. C is equal to A times G divided by G plus 12. Now, anytime we have a formula like this, where we have 1, 2, 3 different variables, it's important we label our variables because they're going to give us values for them, and we're going to be able to solve for them. So C is a child's dose of medication. That's what C stands for. A is an adult's dose of medication, and G is a child's age. So the question asks to calculate a child's dose of medication, again, which is C, when an adult's dose is A and a child's age is G, are known. So we're talking about adult's dose and a child's age are known. Suppose the adult dose for a certain medication is 600 milligrams. So let's make sure we write that down. An adult's dose is equal to 600 milligrams of this normal medication. Determine the corresponding dose for a 3-year-old child. So G, our child's age, is 3 years old. Okay? So we have two of the major variables. We have A, which is 600, and we have G, which is 300. So what we're going to do is we're going to move our Young's formula down here. And we're going to plug in values, okay? So for A, we're going to be plugging in our 600. And for both G's in this equation, because there's 2 G's, we need to plug in 3 for both of those. So our equation is going to read, and I'm going to write it on black to the right, C is equal to 600 times 3 divided by 3 plus 12. Okay. So for some of you, this is where calculators are definitely going to be needed. Make sure you get them. 3 times 600 is going to be 1,800. 3 plus 12 is going to be 15. Okay? Remember, we're working with our bed mass here. I'm taking care of my top multiplication, top part of the fraction, and I'm taking care of the other part, which is 3 plus 12. Now, this is a division sign, so we're going to divide our 2 terms. We have 1,800 divided by 15 equals 120. So, we got our C value to be 120. We need to make sense of this in a concluding statement. This is where you guys get a lot of your communication marks. Therefore, the child's dose of medication is 120 what? Milligrams. That's right. The adult's dose was in milligrams, so we are calculating the child's dose in milligrams. So 3-year-old child should get a dosage of 120 milligrams when an adult's dose or an average adult's dose is 600 milligrams for this medication. Example number 2. It says that a landscaper wants to estimate the cost of fertilizing a triangular lawn. So let's start off by putting some kind of diagram out here. We have a triangular lawn, and it says the side lengths are 150 meters, 200 meters, and 300 meters. So we're going to have a 300 meter, 200 meter side, and a side that is 150 meters. It also tells us, because he's trying to estimate cost, that a bag of fertilizer costs $19. So this is just some knowledge we have. $19.98 per bag. And a bag will cover 900 meters square of area. Okay? So we need to estimate how much it's going to cost us. It says she uses Heron's formula to determine the area of the lawn. The area of a triangle with sides ABC is given. So we got a label. First of all, we have our Heron's formula. This is the area. Area is equal to the square root of S times S minus A, S minus B, S minus C. Now, A, B, and C are the names of our sides. So I'm going to label our triangle. This is my side A, B, and C. So I've taken care of those variables, A, B, and C. The other variable is S, which shows up quite a few times in Heron's formula. And to calculate S, we have to use our sides A, B, and C. So in order to find out the area of the triangle, the first thing we need to do is actually calculate our S. So we're going to move that formula down. We're going to move our S formula down. We know that our A was equal to 150 meters, B was equal to 300 meters, and C was equal to 200 meters. So we're going to be replacing our A with 150, B with 300, and C with 200. So our variable S is equal to 150 plus 300 plus 200. All divided by 2. We're going to need to calculate that. So we have 150 plus 300 is 450, plus 200 is 650. So S is equal to 650 divided by 2. S will be equal to 325. So our S variable is 325. The problem is we're not done yet. All that did was solve for our missing variable in Heron's formula. We had our A, B, and C. We now have our S, which is 325. And I have to plug that in 4 different times. So we're going to go to another page so we have some room. Okay, so this is the main formula we're working with, which is the area. Remember, we stated that A was equal to 150, B was equal to 300, C was equal to 200, and we just discovered that S was equal to 325. So we're going to plug those all into Heron's formula. We get A is equal to, and we're going to need a square root here. The square root, hopefully this will fit, of 325 multiplied by 325, subtract 150, this is definitely not going to fit. Move it down. Times 325 minus 300 times 325 minus, I'm going to write this extra big just to take up the rest of the space there.
There's no bracket to it, isn't it?
Oh, no bracket. Might as well go home now.
You said there's no bracket. There's room for the bracket.
Okay.
Nope.
So, we've now plugged in our formula. Remember, when we go to solve this, we need to work on bed mass. So again, this is all going to be under the square root of. And what we're going to do is we're going to actually work with the brackets first. I need to solve each pair of brackets before I can get to multiplying all the terms by each other. So we get 325 multiplied by 175 multiplied by 25 multiplied by 125. Okay? now that we have that, we're going to multiply all of those on our calculator here and put them under a square root. We're going to get 325 times 175 times 25 times 125. Our number is 177,734,375. Very large lawn.
People don't understand. But like in the book was really necessary.
Okay, so we have such a large number. We still need to square root this. So on my calculator, lucky for me, if I keep my answer in the calculator, all I have to do is hit my square root button, and it gives me a value. Our value is 13,331.7. So what we've just found is the area in meters squared of this triangle. So that's great. We have the area. We went through Heron's formula and we solved for S. The only thing now is I need to actually calculate my cost. So if you guys recall from the first page, we had the note that a bag of fertilizer was $19.98. Per bag. And a bag covered 900 meters squared. Well, our lawn is 13,331.7 meters squared. So I need to figure out how many bags of fertilizer I'm going to use to cover this lawn. So what that means is I need to divide this, which is our area, by our 900 to find out how many bags we're going to need. So, bags needed is equal to, so we take that area of our lawn, which is 13,331.7, and we're dividing by the area that a bag covers, which is 900. Luckily, I've kept that number in my calculator. All I have to do is hit divided by 900. We need 14.81 bags. 14.81. So that's the amount of bags needed. Now, if I'm going to purchase a bag from the store, do you think they're going to sell me 0.81 of a bag?
Yeah, you should.
They won't.
They're Chinese and they're really good at math.
They won't. How many bags are we going to need?
15.
Approximately 15 bags. So, we have to calculate the cost, which means we got to multiply our cost per bag, which is $19.98, times the 15 bags. So our 15 bags times $19.98, $299.70. So this was the answer we were looking for. The cost of fertilizing the lawn, $299.70, pretty much $300. So example 3 is another word problem. Again, it says a landscaper uses a bucket with a radius of 18 centimeters, which is our bucket over here. Radius is 18 centimeters, and a height of 18 centimeters. To pour soil into a rectangular planter, so this is our rectangular planter, which measures 1 meter by 40 centimeters by 20 centimeters. How many buckets of soil are needed to fill the planter? So we need to figure out how many times we have to fill this and dump it into that. That's the entire goal. So what that means is I have to figure out how much this bucket holds, and I need to figure out how much this planter holds. Not only, this is a volume question. So we're figuring out how much something holds. That means I need to find the volume of this rectangular prism and the volume of this cylinder. Okay? Now, first of all, before I do anything, I need to make sure all my measurements are in the same. I have centimeters, 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 meters. I need to convert this meters. What is it in centimeters? 100. 1 meter is equal to 100 centimeters. Okay? So we have that. Now, they actually haven't given you any formulas. This is stuff we covered in chapter 2. So first of all, the volume of our rectangular prism, the volume of our rectangular prism, we'll call it, is the base times the height times the depth, or length times width times height, whatever you want to call it. So this will be our base, our height, and our depth. We're going to be plugging those values in, which means we have 100 times 20 times 40. We go to solve it, that's 2,000. I think it's 80,000 centimeters cubed. So we've discovered that this planter holds 80,000 centimeters cubed of volume. The next thing we have to figure out is the volume of our cylinder. Now, a volume of a cylinder is a little trickier. The volume of our cylinder is essentially the area of the circular part multiplied by the height. So we know this 18 centimeters is our height, and the radius, or r, is 18 centimeters. I need to remember my volume formula. My volume of a circle, okay, is pi r squared, or sorry, area of a circle times the height. That's what volume of this cylinder is going to be. So area of a circle is pi r squared times our height, which is 18. Our h was 18 in this question, and our r was 18. So the only other thing I need to plug in for now is my radius. So in this question, we're going to have volume of a cylinder is equal to pi times 18 squared multiplied by 18. We'll try to do this in a few steps. 18 squared, 324. Times 18. 324 times 18 is pi times 5,832. And finally, 5,832 times pi is 18,321.8. And again, this is in centimeters cubed because we found volume. So we have our two measurements. The volume of the planter is 80,000 centimeters cubed. The volume of our cylinder is 18,321.8 centimeters cubed. Again, similar to when we were calculating the number of bags needed for area, we have to figure out how many times this number is going to fit into this number. How many times our cylinder object is going to fit into our rectangular planter. Okay? What will our formula be again for those two numbers in order to figure out? So we have volume of the rectangular object is 80,000. Volume of the cylinder is 18,321.8. To figure out how many times the cylinder goes into the rectangular prism, what calculate? So what we need to do is we need to divide these two terms. Because we're trying to figure out how many times this fits into this, we're going to divide 80,000. So this is going to give us number of refills. So we're going to take our 80,000 and we're going to divide it by the volume of our cylinder, which is 18,321.8. We put these two in a calculator. We get 80,000 divided by 18,321.8. We get 4.36. Could say is approximately 4.4. So how many refills or how many times does our cylinder fit into our rectangular planter? What is it, Heron? Yeah, 4.5 would be a great idea of how many times you need to refill it. 4 full times and then a half to fill that entire planter. 4.4, which is, if we are going to round it again, we could say 4.5 would be how many refills of our cylinder we're going to need.